Section 3.2 Interactive Assignment Objective 3. And here we want to find the variance for two sets of data. So the following data for a random sample of banks in two cities represent the ATM fees for using another bank's ATM. Compute the sample variance for ATM fees for each city. So we're going to find the variance for both city A and city B. So in here, I've put in the information. So there's city A and there's city B. And so the first thing we need to do is we need to find the sample mean for city A. So here is our first column. We have 1.25, 1.0, 1.50, 1.0, 1.50. So in order to find the sample mean of city A, we're going to find the sum of those values and divide it by 5. So 6.25 divided by 5 gives us a sample mean of 1.25. So then we create a column that has the sample mean of 1.25 for each cell. Okay, next we want to find the deviations about the mean. So that means we're going to take the x value or the data value, which is 1.25, minus the sample mean to get a deviation of 0. Likewise, we're going to take the data value of x, which is 1.0, subtract the sample mean to get a deviation of negative 0.25. Next, we're going to take the data value of 1.50, subtract the sample mean to get a deviation of 0.25. And again, we're going to take the data value of 1.0, subtract the sample mean of 1.25 to get a deviation of negative 0.25. And then the last one, we're going to take the data value of 1.50, subtract again this 0.25. And now what we're going to do is we're going to take the deviations and square each one of them. So we take 0.0 and square it to give us the value of 0. We're going to take the deviation negative 0.25 and then square it to get 0.0625. We're going to take the deviation of, that should be 0.25. So making the correction, if we take 0.25 and square it, then that's going to get us 0.0625. And then again, if we take negative 0.25 and square it, then that's going to give us 0.0625. And again, if we take 0.25 and square it, then we're going to get 0.0625. So now we're going to total up the squared deviation about the mean. So, and we add those all up, then we get 0.2500. And now we're going to plug it into the variance formula. The variance, for the sample variance, the symbol is s squared. Okay, so we're going to take the numerator, which is 0.2500, which is the sum of the squared deviations. And then we're going to divide it by the sample size of 5 minus 1, which then gives us 0.2500 divided by 4, which gives us 0.0625. We're going to round the variance to the nearest cent, so the variance for city A is going to be 6 cents. So, coming back here, we get 6 cents for the variance. Okay, now we're going to do the same thing for city B. So we're going to find the mean, or the sample mean for city B. So we're going to add up all those numbers, 2.25 all the way to 1.75, and divide it by 5. So 6.50 divided by 5 gives us a sample mean of 1.30. Now again, over here we have our column for city B. And then what we're going to do is we're going to put in our sample mean of 1.30 for each cell. And then what we're going to do is we're going to take each data value, so 2.25, and then subtract 1.30. Again, 1.50, and then subtract the sample mean of 1.30. The data value of 1.0, and then subtract the sample mean of 1.30. The data value of 0.00, and then subtracting the sample mean of 1.30. The data value of 1.75, and then subtracting the sample mean of 1.30. Now when we subtract them all, we're going to get the deviations of 0.95, 0.20, negative 0.30, negative 1.30, and then 0.45. And now we're going to take each deviation and then we're going to square it. We're going to square 0.95 squared to get 0.9025. Square the deviation of 0.20 squared, and that gives us 0.0400. Square the deviation of negative 0.30 to get 0.090. Square the deviation of negative 1.30 and square that to get 1.6900. And then square the deviation of 0.45 to get 0.2025. So again, now we're going to add up everything in this column to get 0.9025, 0.0400, 0.0900, 1.6900, and 2.2025 to get a total of 2.925. So remember again, our formula for the variance is taking the sum of that last column, which is 2.925, and then we're going to divide that by the sample size of 5 minus 1. And so by doing that, we're going to take 2.925 divided by 4 to give us 0.73125. And then rounding the variance to the nearest cent is going to be 73 cents. And so therefore we get 73 cents for our city B for the variance.